All right, are there any questions on the first one? You're on a unit circle. So that's why you notice that the x and the y are both fractions. The x and the y, if they're greater than 1, cannot be on the unit circle. And everybody's good with this. Stop me if you have any questions. First couple I turn that over here. The second one down here, this is just a triangle. So everything's going to be positive. If it helps you, reduce them all. See my circles, the 3, the 5, and the 4. This is your 3, 4, 5 triangle. Just reduce it first, and then you don't have to reduce it at the end. Don't give me a decimal. Always give me a ratio, because these are trig ratios.
So we didn't have to do the smaller triangle?
Sorry?
We have to do the smaller triangle?
I don't know what that smaller triangle is there for. I'm sorry. I don't know why it's there.
Okay.
It's not the same triangle. You did the smaller one, whichever one you did. It is the same triangle?
Both sides by 4. You get the...
We'll divide both sides by 4. Very good, then you do. Thank you. So if either way, they're all going to reduce down to the same thing. I didn't know why that was there. I guess that's why it's there. You got 50 what? So don't leave me decimals. Make sure you reduce your fractions. Okay, now I should be up. I don't know what happened here. That's worse. Is that better or worse? I don't know what happened to this. I got like 2 versions of Word on here, so I think that's a problem. Alright, let's see if we can make heads or tails out of this. These are important. We gave you a function. And usually they have to tell you what quadrant it's in. If my sine is equal to 5 over 6, why do I have to tell you what quadrant it's in? It's positive. Why do I have to tell you? Where would you go to put it? It could be in the second one. Good, Danny. It could be in the second one. Because sine is positive wherever y is positive. So quadrant 1 or quadrant 2, which would change not the value of the numbers itself, but the positives and negatives. Cosine would be negative over here. Tangent would be negative in quadrant 2. So it's going to narrow down. It's got to tell you where to put these. I don't know if you could see these for some odd reason. It's this word thing that's making my thing go crazy here. There. Better? Alright, so now, find the pieces that you have. You have, if you need to say opposite over hypotenuse, get used to saying y over r. Take SOHCAHTOA and change it. You still got your sine, your cosine, your tangent. Your radius is your hypotenuse. X, Y, A, O. All your A's are X's. All your Y's, all your O's are Y's. Get used to seeing sine y over r, cosine x over r, tangent y over x. Make this little information box. Easiest way to do this. And from there, you can do all your parts. Reduce your radicals. Reduce your fractions. If it's easier, reduce it first when you get it into your information box. Everybody okay with this? Everybody getting used to the x, the y, the r? Kind of? Okay. Here's another one. I have a secant. So I need to have some kind of ratio here. So I say 4 over 1. Secant is the reciprocal of which one? Cosine. So if it helps you, say cosine. 1 over 4. Work from there. Cosine is my x over my r. Find your missing part. You don't have to work off the reciprocals, just flip them back over. And then make your information box. You're still in quadrant 1. Leave your radicals in the denominator. You don't have to rationalize those. It makes it a lot easier when you take the reciprocals. All you gotta do is flip them over. Okay. All right. Tangent 3 to 3 over 1. You're still in quadrant 1. You got y over x. Find the missing part. Cotangent, I don't know what this says because this came right on top of this. 2 over 3. 3 over 2. 3 over 2. Find your missing parts. Pythagorean's theorem. You good with those, guys? And the bottom part, same thing. It says find the theta in the degrees from 0 to 90, or from the radians 0 to pi over 2. So what quadrant am I looking for? Quadrant 1. From 0 to 90, quadrant 1. Same thing you just did up there. Same exact thing you did. It just looks a little bit different. And again, you're in quadrant 1. So this time you had to find the angle. So these have to be your special angles. I can ask you to, well, I can, if you pick up your calculator, if we can ask you to do that. But the ones that you get your special triangles for are the ones that you're usually going to find your angles. So I've got a sine of 1/2, y over r. Set this up. What's that angle as a reference angle? Opposite the 1 is 30. I've got a 30-degree angle, and in radians, 30 goes into 180 how many times? 6. So pi over 6. This guy has a cosecant of 2. So I'm really not fond of my reciprocal functions because they don't make any sense to me. So what is the cosecant a reciprocal of? Sine. Just flip it over. Isn't that the same as that one? Use your regular functions. If you don't like the reciprocals, you'll get used to them, but just flip them back over. And again, 30 goes into 180 6 times. Secant, reciprocal of cosine. Now, these are your cofunctions. Your sine of 30 was 1/2, so your cosine of 60 has to be 1/2. Those are your cofunctions. And yep, 60 and 60 goes into 180 3 times, pi over 3. Cotangent is 1, make it a ratio, 1 over 1. Well, that's both of your legs. Both of the legs on a right triangle, if they're equal, has to be 45 degrees. We're good with these? These are your special triangles. These are the most important ones. And the last two, this guy, sine is radical 2 over 2. So radical 2 over 2, that's your 45, 45. If you want to unrationalize that one, or keep it like that, then you're going to have to look for your third side, and then figure out that it's a 45 degree. Do it that way. You can unrationalize these guys. I find it easier to unrationalize them. Then those little pieces pop out. Radical 3, radical 2, those little pieces pop out a little bit better. 71, which one? First one or the second one? First one. So if we're a cosecant of 2 radical 3, what's the cosecant reciprocal of? Sine. So if you do y over r, okay? Now, when you do this, you're going to have to find the other side because this doesn't appear to you like a special right triangle, right? So when you find the other side, it's going to have a radical also, right? It's going to probably be radical 3. You have to do Pythagorean's theorem. Because it's a special right triangle. It's a special right triangle. So if this is the side, this is 2 times the side. So 2 times the side, my side has to be radical 3. No. No, because then this would have to be a radical 2, not a radical 3. 45 has to have a radical 2. So if you did this, 2 radical 3 squared equals 3 squared plus x squared. So this gives me 4 times 3, 12. So this gives me, subtract the 9. So x is equal to radical 3, right? So this is my side, my 2 sides. See it? Multiplied by 2. This is my side radical 3. So if I take my radical 3 times radical 3, isn't this a 60-degree angle? It's harder to recognize without unrationalizing, but you can do it. Because my triangle says side 2 times radical 3. This one says radical 3 times radical 3. In a 30, 60, 90, normally it looks like this. It only has one radical. Opposite the 60 is a radical. If opposite the 60 is not a radical, then the other 2 sides have to have radicals. I find it easier to do this. It must have been that they rationalized the radical 3. If I multiply top and bottom by radical 3, don't I get this? Unrationalize it. So now it's going to make more sense. So when I flip this over, I get the sign of radical 3 over 2. Doesn't that make better sense? Why? And isn't that my 60-degree triangle? It's harder to see after they rationalize it.
I get that, but why do you use the 60 degree?
Because that's your reference angle. That's opposite this piece right here. That's this angle right here. 30 is up here. Still don't see it. It's got to be opposite the... Is it this triangle that's throwing you off?
I was doing this yesterday.
So what did you get when you did Pythagorean's theorem? What did you get for this one?
No, I didn't.
You did it. Okay, so when you're missing a side, Pythagorean's theorem, we found this to be radical 3. And like I said, once they rationalize it, it doesn't look like our normal 30, 60, 90. But your rule says side. See, right here is where you should recognize it. From radical 3 to 2 radical 3, what did I do? By 2. So if this is a side, this is 2 sides, and I multiplied it by 2. So this should be side times radical 3. See it? So isn't radical 3 times radical 3, 3? Right? What I'm saying is this. You can figure these out by going back to the formulas. This one right here should be telling you, I multiplied this by 2. Where else did I multiply this by 2? At my 30, 60, 90, I take a 1, multiply by 2, I get the 2. It's sometimes easier to unrationalize this first. Take this one. Everybody knows radical 2 over 2, right? You did this last year. Isn't radical 2 over 2 one of those things you just kind of feel comfortable with? No, you don't feel comfortable with it. You don't recognize that as a 45 degree? Alright, so if I unrationalize this guy, this is why I say it takes a little while to get used to this. If I unrationalize this, isn't it this? Because didn't I multiply top and bottom by radical 2? Right? Just divide both by radical 2. Just get it out of there. So now, this I recognize easier because it's 1, radical 2. Both this side must be a 1. It has to be a 45 degree angle, right? If I do this, so I say sine is y, and it doesn't really matter in this one, 2. God bless you. So I still don't recognize this, so I say 2 squared equals radical 2 squared plus x squared. Again, 4 equals 2 plus x squared, subtract 2. Oh, this also gives me radical 2. Do I now recognize that as a 45 degree triangle? Because the legs are the same? That one's easier to recognize. Because your pattern says S, S, S radical too. But the other one, you gotta go by the pattern. S, 2S, S radical 3. This one's fun. So what I'm getting at is this. Normally we see this one as a radical. If the radical is not a radical, the other guys have to have radicals. They're just a little trickier to recognize. So unrationalize your fractions first. Yes.
I'm getting like the many of the sides, but for 71, I thought the angle that would use would be 30 degrees because it's opposite from the side. Like we found that 3 and then opposite that, is that 30?
Opposite. Let's go back to, where are you? This triangle right here? Are you at this triangle right here?
Yeah. How 30 is usually across from 1, she thought it was across. No, well, in that picture, radical 3 is across from 30.
You're right. You're right. Radical 3 is across from 30, but it's up here. Your reference angle is here. Because your reference angles, all your angles start here and rotate around like this. Remember my bow tie? All your reference angles come up from here. It does matter what side it's across from. Okay, so let's just go back to this triangle. Okay, I get what Amani's saying, because this one's harder to recognize. What's the smallest number out of 2? Put these in your calculator. 2 radical 3, 3 radical 3. Obviously we know 3. This is 1.7. This is 3. Put this in your calculator. 2 times radical 3. So we multiply this by 2. So it becomes 3.4. Which one is the smallest side out of these numbers? Radical 3. So radical 3 has to be opposite the 30, which it is, right? But my reference angle is this guy down here. This is my reference angle right in here. It has to come off the x-axis. Because when you start your angles, they start right here. And they rotate around like this. They're right in here. So those triangles, that's where your reference angles come out. 30 is opposite the radical 3, but it doesn't touch my x-axis. It has to come off my x-axis. That make more sense? Okay. We good with this? I'm leaving the first 2 for you, because those are your special triangles. You'll get used to seeing those. All right. I need you to get used to seeing your special triangles. All right, take a look at number 15. Oh, a point is on the terminal side of an angle in standard position. We just need to find the sine, cosine, and the tangent. So we need to locate this guy. So what quadrant does 7, 24 fall in? 1. Which means I start my circle here. I go counterclockwise, and then somewhere over here is 724. This is my x, this is my y. So if I came around my circle, I'd be like that. So this is my terminal side. I drop a triangle, a right triangle. This is my x, 7. This is my y, 24. I have to find my radius. How do I find my radius? Pythagorean theorem. So find me the radius. What we get?
I need a calculator.
1, 5. This is one of your triples. Okay. So now, once you have this information, sine. Y over R. Cosine. X over R. Tangent. Y over X. Just fill them in. If these can be reduced, reduce them first. And then you're not stuck reducing every single one of those over there. But obviously these can't be reduced. So 24 over 25. x over 25. 24 over 7. Good? Okay, the second one works kind of the same way, right? You just have to locate what quadrant it's in, find your missing side. Your radius is always positive. This guy. What does it mean when I say less than 0? Negative. And greater than 0 would be positive. So, sine. Is sine my x or my y? My y. Cosine my x or my y? So now, I look at this, I say, where is y negative? In what quadrants is y negative? Third and fourth. I put check marks. Then I look at the second part. I say, where is cosine negative? Where is my x negative? What quadrants? Right over here, right? 2 and 3. Where do they overlap? 3. So my angle is located in quadrant 3. So I'm really not sure if that's true. So give me an angle from quadrant 3. Give me any angle. 200. Okay, this has to be past 180 before 270. So I'm going to say, give me the sine of 200. Is that negative? Mm-hmm. Give me the cosine of 200. Is that negative? Whoops. It's consistent and press cosine. Yep, that's negative. So is that good? Mm-hmm. Okay. You can, I don't know if they taught you last year, all students take chemistry, take crack, take calculus, whatever. This means all are positive. This means just the sine is positive. Tangent and cosine are negative. This means just the tangent is positive. Sine and cosine are negative. Excuse me, this means the cosine is positive. Tangent and sine are negative. I personally like to do it this way. Sine is your y, so you visualize here on your axis. This is why we superimpose your circle onto your axis. So where is your y's negative? Right down here. Where is your x is negative? There's my x negative, right over here. You can do it either way. Okay? Or you can pick angles and try them. So I'll leave that one for you on the other one. I'm just trying to pick like one from each so that you don't get confused. Okay, let's pick this guy. Let's do this one. Oh, you know what? Let's do this one. Tangent is negative. Okay. And my sine is negative. Where is my sine? My sine is my y. What quadrant is sine negative if it's my y's? Below the x-axis, so 3 and 4. Of those two quadrants, where is tangent negative? 4. Because in 3, x and y are both negative, so a negative divided by a negative gives you a positive. So my angle has to be in quadrant 4. Okay, so this is what we did. We looked at the signs. Where is the sign negative? The signs are y's. Somewhere down here. Anything where my y is negative. Down below the x-axis, 3 and 4. Of these, so I could be either here or there. But in this case, these guys are both negative. So a negative divided by a negative makes my tangent be positive. So therefore, tangent is negative over here. So I'm going to say, not this guy. I'm going to look at this one. Tangent is what parts? Y over x. Now notice the negative is sitting out front. Leave the negative there for a minute. This says 15. This says 8. First, find the R. find me r. We'll worry about the negative in a minute. What do we get? Okay, now, in quadrant 4, is the x negative or the y negative? The y. So even though my tangent said this, negative out here, one of these has to be negative. Don't assume it's the top, don't assume it's the bottom. Lay out your triangle first and then say, well, in this quadrant, my y is negative. So this guy has to be where my negative is. I could do this. I could even do this. I could give you this. And my 15 could still be negative. Does it matter where I put my negative in my fraction? No. Whether it's the top, the bottom, or outside of it, it's still a negative. So don't let that negative sign fool you. Find where your quadrant is, and then you can find all your parts. Okay? And let's take one of, and then you can find your cosine. What did they ask you for? Sine and cosine and tangent. You guys can find that, right? Use these pieces. Okay, and the last part, so I'm looking at this guy, negative 750, and they want me to say, give them the sine, cosine, and the tangent of 750. Negative 750. Where do I start? Find out what quadrant. So I'm going to start. Am I going to go clockwise or counterclockwise? Clockwise, because I'm going negative. I know it sounds the opposite way, doesn't it? Normally you would say negative, you do the counter, but it's the opposite. So I got 360. So let me see how many 360s I can get out of 750. So I do this, and I get 390. That means, can I do another 360? So let me go again. God bless you. To 360. And I have 30 left over, which means I'm coming down here 30 degrees. So what's my reference angle, Amani? 30 degrees. This guy right here. So, oh yeah, I know what this triangle is. 1, 2, radical 3. Doesn't say it has to be in a unit circle. You can do whatever one you like. So my x is radical 3. My y is negative 1 because it's down here. And my radius is 2. Can we find these? Good? Yes. The radius is always positive. Always. The radius is a distance measured from the center to the side of the circle, so it has to be positive. I kind of go with the fact that my x and my y, when I put it on my triangle, are also distances. So I don't put the negative signs there, but you can gladly put the negative signs on your triangle. A lot of kids like it there instead of in the box.
Can you do one that says?
Oh, the radian guys? Which ones you want to do? All right, let's pick this guy. 11 pi over 4. So I remember saying, okay, this is the 0. This is 4 pi over 4. This is 8 pi over 4. But for some reason I'm 11. So what should I do? I come around here. I came here. I came to the 8. I have to go more. I have to go to 11. So if I add 4 more to this, what do I get? If I add 4 more to this, yeah, God bless you. If I add 4 more to this, what would this one be? We'll add 4 more to this, to 12. 16. So this, isn't this 2 pi, isn't this 4 pi, right? So now, I'm coming around and I want to stop at 11. This guy is 12. So what quadrant am I going to end up in? 2. I'm going to go here and stop. I'm going to drop a triangle. How many times does 4 go into 180? 45. Oh, do we all know our 45-degree triangle? 1, 1, radical 2. Who's negative in quadrant 2, x or y? same thing. Didn't we do the same thing with the 360s? We just kept adding the 360. The same thing with the radians. Okay, so you guys have the rest to do.